this kilogram, that kilogram will cancel, this secant squared and this secant squared will cancel, and that will leave us with 9,810 newtons per meter squared. And that is a force. A newton is a force. And this is an area. And that is actually equal to 9.81 kilopascals.
I bet you're really happy that we didn't cover that kind of stuff. That would, of course, be force over area. That's pressure in a slack tube manometer. Aren't you happy you've got a DG700 that does all those calculations for you? I certainly am. So let's take a look at a little bit about differential pressure, because it's a topic that we really should have covered this morning in our discussion, and we didn't. And I think it bears a lot of mentioning because we always measure differential pressures. We're always measuring, say, house with respect to outside, flue pipe with respect to CAS, etc. So I found a video that explains how differential pressure is measured using a pitot tube. You can use a pitot tube to measure differential pressure, and the video shows how that's done. It's really similar to what the Model 3 fan is doing, and then how it's relaying that information to the DG700. So the Model 3 fan has a white ring mounted on it, and the white ring is connected to the pressure tap that you usually connect your red tubing to. It's on the top of the fan housing. And the white ring also has 3 or 4, I think it's 4 small holes drilled in it, and those holes are the pressure sensing holes. And so it's simply a pressure sensor. It doesn't calculate or anything of that nature, but it's a pressure sensor of a known size with known sized holes drilled in it. And that pressure is transmitted back to the DG700. So if you remember, when we measure fan flows, we're looking at pressure of the fan as an input to the pressure in the house. I think that's right. I have to review that. Let me get my DG700. Yep. Got it right here. So we're measuring house to outside, and that tells us how many pascals we've depressurized the house by. And then on the other side, we measure fan to house, and that'll tell us what the flow is. So let's take a look at the pitot tube video. I think it's kind of cool.
One principle is flow measurement based on dynamic pressure detection using a pitot tube. Some 300 years ago, Swiss mathematician and physicist Daniel Bernoulli discovers a direct relationship between the pressure and speed of a fluid flowing in a pipe. At the same time, the French engineer Henri de Pitot is constructing a device for measuring the traveling speed of ships using flow pressure. His instrument is known as the pitot tube. Here is how this measurement method works. Pitot tubes have a rod-shaped measuring element that is inserted into the pipeline perpendicular to the flow direction. On the front and rear of this probe are several holes. 2 separate tubes connect these holes to a differential pressure sensor. With its 2 pressure chambers, separated by a diaphragm, the tiniest pressure differences in the flowing fluid can be precisely measured. The individual pressure taps are distributed along the entire pipe cross-section to ensure a representative measurement. If the fluid is not flowing, the pressure before and after the probe is essentially the same. As soon as the fluid starts to flow, an additional impact pressure against the front of the probe is generated, also known as the dynamic pressure. On the rear of the probe, in contrast, only the static pressure, which is not related to the flow, is still measured. As a result, different values are detected in the pressure chambers of the sensor. Higher pressure against the flow and constant pressure on the rear of the pitot tube. This pressure difference is a direct measure for the flow velocity and thus the mass and volume flow in the pipe. The higher the flow velocity, and therefore the dynamic pressure, the greater the differential pressure measured. A unique feature is that pitot tubes can register flows in extremely large pipelines. This advantage applies not only to square ventilation ducts, but also to the measurement of flue gas or exhaust emissions in large chimneys of up to 12 meters in diameter.
810 kilograms per meter second.